So welcome to the review of the new basic questions effective July 15th, 2025. We'll now do sections 316 to 321. Again, any new question is in bold. And again, the formulas and functional diagrams may be useful in the next few sections. So this is what the study aid looks like, which explains what these formulas or diagrams are. And what you can take into the exam as a reference aid is the same material without the words. So it doesn't tell you what these things are. So we're doing operations technical, and we're covering 16 to 21 today. So 16 is batteries. What is the approximate voltage does a standard automobile starter battery usually supply? So an auto battery is 12 volts. Which of the following has a positive terminal and a negative terminal? So if you look through here, the answer is C, a battery. A battery can be repeatedly recharged by supplying it with electrical energy, and this is known as, so a battery that can be charged is known as a storage battery. Which of the following is a source of electromotive force, EMF? That's the same as voltage, and that here would be a lithium-ion battery. Why is a nickel metal hydride battery or a NiMH battery often preferred over conventional alkaline batteries? And that's because it can be repeatedly recharged. An alkaline battery cannot be recharged. The voltage at the battery's terminal will drop when it supplies current. What causes the drop? So the battery itself has an internal resistance. So it is due to the internal resistance of the battery. And that's why the voltage drops when it supplies a large amount of current. A new question. For portable operations, what is the primary advantage of lithium-based batteries over lead-acid batteries? And that's higher battery capacity per kilogram. So B is the correct answer. Battery capacity is commonly stated as a value of current delivered over a specific period of time. What is the effect of exceeding the specified current? So if you exceed that, you'll discharge the battery faster than specified. So B is the correct answer. Here are some questions about connecting batteries together. Again, before you do this, make sure that you check with the battery manufacturer, because some batteries are not meant to be connected together. So if you have two 12-volt, 20-amp-hour batteries and you connect these two batteries together in parallel, the voltage remains the same and the current goes up. So the correct answer here is B, 12 volts, 40 amp hours. Now, if you connect the same two batteries in series, the opposite happens. The voltage goes up, but the amp hour capacity remains the same. So the answer here is B, 24 volts at 20 amp hours. Lithium-ion batteries should never be. B is short-circuited because it has a high amount of current. It can cause a fire, or the battery can explode, or both. Actually, any battery should not be short-circuited. Here's a new question. You construct a simple DC power supply using a transformer, rectifier, and filter capacitor. If you use this to supply to power a CW transmitter, what problem are you likely to have cause? And because you don't have a regulator in your power supply, the voltage goes up and down as it transmits, so you're going to introduce chirp. What device converts 120 volts AC to 12 volts DC? So here, this would be D, a power supply. When selecting a 13.8 volt DC power supply for a transceiver, what design specification is most important? So because some of the transceivers can use a large amount of current, you want to make sure that the power supply can actually supply the 25 or 30 amps of current that you need. So B is important, your output current capability. Here's a new question. This is comparing switching and linear power supplies. Comparing a switch mode power supply, why may a linear power supply be preferred? And generally, linear power supplies are a lower risk of producing radio frequency noise. So C is the correct answer. Here's another question. In a mobile installation, why should the fuse in a DC line to a transceiver be located as near as possible to the battery? So B is the correct answer, to protect the entire circuit. Because if you create a short circuit, you don't want the battery involved, so you have the fuse as close to the battery as possible. Another question, apart from efficiency, which one advantage of a switching power supply over a linear power supply? And here, a switching power supply is smaller in dimensions and also weight compared to a linear power supply. Another new question, why are heavy gauge wires used for a 100-watt transceiver DC connection? And here, what you want to do is prevent, because it takes a large amount of current when you're transmitting, you want to minimize the voltage drop in the wire, and that's why you need to use a heavy gauge wire. What is the nominal power supply voltages supplied to homes? So the correct answer is 120 volts and 240 volts. Here is this question. Your transceiver's user guide suggests limiting the voltage drop to 0.5 volts, and the vehicle battery is 3 meters away. Given the losses listed below at the required current of 22 amps, what is the minimum wire gauge that you must use? So when you go through the calculations, the correct answer is A, number 10 wire. The trick here is to remember that you have 2 wires, not just 1 wire. So you're actually doing the calculation for 6 meters, not for 3 meters. You can also use number 8 wire, but they'd ask for the minimum wire gauge. So 10 is smaller than 8. So the correct answer is number 10. Why must the positive lead from a vehicle battery to the transceiver be fused? That's again to prevent an overcurrent situation from starting a fire. B is the correct answer. How you may have a very loud, low frequency hum appearing on your transmission. In what part of the transmitter would you look for the trouble first? And what you would do here is look at the power supply. What you can also do here is run your transmitter with a power supply, and also run it with a battery and see if the hum disappears. The hum disappears, it's your power supply. How could you best keep unauthorized persons from using your station at home? Now we're on to electrical safety, and that's A, is to use a key operated on-off switch for the main power line going into your home, into your home station. How could you keep unauthorized people away from using your mobile station in the car? And the simplest way here, if you can, is remove the microphone when you're not using it. Here's a new question on electrical safety. What electrical hazard, if any, does the start of battery in a vehicle represent? So a battery generally has a high amount of current. So C, high short circuit current is what you have to be careful of. Why would there be a switch in the high voltage power supply to turn off the power if the cabinet is opened? And that is to keep anyone opening the cabinet from getting shocked by the dangerous high voltages. So you have a safety switch built into the cabinet. What is the minimum electrical current that can be fatal to the human body? So in this case, it's 20 milliamps. So 28 milliamps can kill you. Which body organ can be fatally affected by a very small amount of electric current? And that would be C, that would be the heart. The heart would stop beating. What is the lowest voltage that is usually considered hazardous to humans? So here, the lowest voltage is 30 volts. So anything higher than 30 volts and 20 milliamps can kill you. What should you do if you discover someone who is being burned by high voltage? So what you want to do is turn off the high voltage first. Turn off the high voltage, turn off the power, call for emergency help, and then provide first aid if needed. What is the safest method to remove an unconscious person from contact with a high voltage source? So the safest way to do it is by de-energizing the power source before touching the person. So D would be the correct answer. If you were to touch the person yourself, you would form part of the circuit and be in the same problem, getting electrocuted as the first person. What is the risk involved in troubleshooting a live power supply? So again, here you have to be careful of electric shock. Next section on electrical safety. What best protection from electrical shock? For best protection from electrical shock, what should be grounded at your station? So all station equipment should be grounded. So D is the correct answer. A new question here. Established practice demands that all ground electrodes be bonded together with heavy conductors. What protection does this provide in case of a lightning strike? So by bonding all of these together prevents voltage differences between the various devices. So A is the correct answer. Why should you never use a fuse with a higher current rating than specified? So B, a fault may cause permanent damage, including a fire. Which of these materials is best for a ground rod driven into the earth? So in this case, it would be a copper, glass, steel rod. C is the correct answer. A new question. You need to work on a power supply that has been taken offline. What is the first thing you should do once the cabinet is open? So because it's a power supply, it most likely will have capacitors in it. So you want to discharge the filter capacitors. Where should the green wire in a 3-wire AC line cord be connected to in a power supply? So C, the green wire is the ground, so it should be connected to the chassis of the power supply. Your third floor station has a ground wire running 10 meters down to the ground rod. You get an RF burn when you touch your HF transceiver when transmitting. What is the likely cause? So here, your ground wire is acting like an antenna, so it has a high impedance on your operating frequency. A new question on electrical safety. If you're using an HF off-center fed OCF unbalanced antenna, when you transmit on single sideband, distorted audio and noise are heard from an outboard amplifier speaker. What device could be installed in the transmission line to mitigate this problem? So this is known as RF in the shack. So a transmission line like a cable is actually three conductors. You're actually getting RF traveling back on the outside of the cable, and you want to eliminate that. So you would use a device called a common mode choke. Here's another new question. What is a safe method to discharge power supply filter capacitors? A is to use an insulated shorting stick with an inline resistor. So the resistor limits the amount of current that can be discharged safely, and you use an insulated shorting stick. On a mains operated power supply, the ground wire of the AC line is connected to the power supply chassis. What protection does this provide if a fault occurs with the power supply? So it ensures that the chassis does not become energized. Some of the older radios, tube type radios that have a plug, a two-prong plug, if you plug them in the wrong way, your chassis actually is connected to the hot end of the power line, and you could get a shock touching the radio. But we don't have those anymore, unless you go to antique stores. Why do fuses have a voltage rating? So this is a new question. So it has a voltage rating to specify the voltage that can be interrupted without arcing. So if you use a fuse at a higher voltage, it could arc over once it blows. So you have to want to prevent that from happening. Why should you, now we're getting into antenna and tower safety. Why should you ground all antenna and rotor cables when your station is not in use? So to help protect the station equipment and building from lightning damage. If you want to install a lightning surge protector on your transmission line, where should it be inserted? So outside, as close to the ground, earth grounding as possible. So A is the correct answer. How can your station equipment best be protected from lightning damage? So disconnect all equipment from the power lines and antenna cables. So B. What equipment should be worn for working on an antenna tower? So here you want some type of approved fall arrest equipment to wear when you're working on a tower. Why should you wear approved fall arrest equipment if you're working on an antenna tower? And A is to limit injuries if you fall. For safety, how high should you place a horizontal wire antenna? And the answer is high enough so that no one can touch any part of it from the ground. Why should you wear a hard hat if you're on the ground helping someone work on an antenna tower? To protect your head from something dropped from the tower. So B is the correct answer. Why should your outside antennas be high enough so that no one can touch them while you're transmitting. A, because touching an antenna might cause RF burns. Why should you make sure that no one can touch an open wire transmission line when you're transmitting with it? And again, because high voltage radio frequency might burn the person. C, what safety precautions should you take before beginning repairs on an antenna? What you want to do is make sure that your transmitter is off and that you disconnect the transmission line. So C is the answer. Here's a new question. What safety precaution is especially important for a ground-mounted antenna? And the answer is D. D, ensure people are kept at a safe distance away from the antenna. Now we're getting into RF safety. So what should you do? What should you do for safety when operating UHF or microwave frequencies? And the thing what we want to do here is keep the antenna away from your eyes when RF power is applied. What should you do for safety if you put up a UHF transmitting antenna? And that's D, is make sure that the antenna will be in a place where no one can get near it when you're transmitting. What should you do for safety before removing shielding on a UHF power amplifier? And what you want to do is make sure that the amplifier cannot accidentally be turned on. So A is the correct answer. Why should you make sure the antenna of your handheld transceiver is not close to your head when transmitting? So the answer here is D, to reduce exposure to the radio frequency energy. How should you position the antenna of your handheld transceiver while you're transmitting? And what you want to do here is point it away from your head and away from others. So B is the correct answer. How can exposure to a large amount of RF energy affect the body tissue? So basically, RF energy heats the tissue. So B is the answer. What body organ is most likely to be damaged by the heating effects of the RF radiation? And that would be C, would be the eyes. Here is a new question. How does the power density of an electromagnetic wave change as it propagates away from an antenna in free space? So what happens here is that the intensity decreases by the square of the distance. So A is the correct answer. It decreases as the square of the distance. If you operate your station with indoor antennas, what precautions should you take when you install them? So here you want to locate the antennas as far away as possible from living spaces that will be occupied while you're operating your radio. Why should directional high gain antennas be mounted higher than nearby structures? So people, remember, you're thinking about safety. So there will not be direct RF energy toward people in nearby structures. You don't want to beam your RF energy into the building next door. For best RF safety, where should the ends and center of your dipole antenna be located? So again, here, as high as possible to prevent people from coming in contact with the antenna. That completes that section. So next week we start on electronics, and we'll cover 1 to 6 next week on amplifiers and diodes and transistors and vacuum tubes and resistor color codes. So that is what we'll cover next week. So let me just stop the recording here.